Visual Studio 2010 has some really cool new graph visualization technology which I'm about to show you. It all starts with the File New menu, where you can bring up a new directed graph document. Directed graph documents are based on an XML file format called DGML, which stands for Directed Graph Markup Language. DGML is able to represent nodes and links in a general purpose graph. There's an XSD schema, so we get some IntelliSense and code snippets, and we can create a graph very quickly. Here we see the visualization of that graph. Let's view it as a tree. On the toolbox here, I've put some more data so we can build up a graph quickly. What does that look like? Okay, here's the visualization. And again, you can look at that in different layouts, left to right, force directed, or a dependency matrix. Now, directed graphs can also contain categories. We can come in here and say, make these green. Categories are stored in the document like this, and you can apply styles that set different UI visualizations for that category. You can also add groups to a graph, and here I'm going to add a new parent group. Groups are actually stored as nodes with a special attribute and as links showing you what's contained within that group. Groups are handy when you want to collapse complexity. Okay, with that foundation, let me show you what you can do with this. This graph here shows actually all the features of graph documents, together with some demos that I'm going to take you through. The first one I want to show you is a graph showing relationships between baseball players. Now perhaps you don't like the color scheme here. You can go to the interactive legend and you can apply a different rainbow setting here, and instantly you can get a different visualization of that data. This graph here contains about 4 megabytes worth of nodes and links of all the pages in the Silverlight documentation library and all the links between those pages, together with page view information, which is colored as a heat map with red, different shades of red, and user ratings based on what pages did the users enjoy reading. This graph here shows object references at runtime, and this graph was generated by a tool from the debugger so that you could get an idea of what was happening at runtime, and it was actually used to track down a memory leak because we're able to trace back through this object graph what was going on. This graph here illustrates how you can use icons to show different semantics of code. Here we've got some UI code calling some networking code, and over here we have some model code behind the UI. This graph here shows code coverage information with different shades of red and green and yellow, and when you find a big cluster of red, that's a great place to focus your next test effort. This graph here shows lines of code information on a dependency graph. So these are classes, and the size of the node represents how much code is in that class. This graph here is all of the binary dependencies in .NET 4.0. If we zoom right into the center here, we can see, of course, that MS Corelib is the major hub, but maybe we care about printing. What this graph document can also do is create a tree out of a graph. If we go into a tree layout here, we'll be able to see that. So it's taken a dense graph and turned it into a tree of nodes that are related to system.printing. You can also double-click your way through this graph and explore different parts of the graph projected as a tree. This graph over here was used to communicate how we wanted to change an interface. So there were a bunch of interfaces and classes related here in an interface assembly, and we're able to use custom styles to quickly communicate which interfaces were going away, which interfaces needed to be renamed, and the green bubbles were showing us what things are external that we can't change. Now I have another version of this graph that we're looking at with a little bit of sparkle. This graph has a background image, has some transparent groups, and we're able to navigate through all the demos. This demo right here is a fun one because it's based on TFS source code change history, where we're able to see code that's modified by developers, and then we're also able to see, when we zoom out, which code is shared by multiple developers. Then what about grouping? This graph here shows a UML meta model organized into a graph with nice colorization in the legend here. You can view this graph in groups, which simplifies the graph. If we select everything, we can see that there's a lot more links than what you see when you have grouping. If you actually remove all the groups, then what you get is a combined graph where you now see how the colors are sprinkling across all these different areas, so you can get a better idea of how these semantic groups are interacting with each other. Lastly, the directed graph document is really designed to scale up to some large graphs. I have a graph here of all of WPF organized by namespace down to the class level. This graph has 1,000 nodes and 3,000 links. We can zoom in and see some semantic zooming happening. We can see the nodes starting to appear, we can see the labels, and we can navigate around this graph and explore the cross-group relationships, who else uses content element, who uses automation peer. We can navigate down there and so on, and we can learn all about how WPF works. I think you'll agree that this is pretty exciting new visualization technology, and I think it's safe to say we'll see lots of cool things that people will build on top of this.